Okay, so for rectilinear motion, I wanted to talk about this using WebAssign rather than going through the PowerPoint situation. So rectilinear motion just basically means motion on a line. And so you'll notice that we're talking about x as a function of time here in this question. So it's x of t. This is straight from WebAssign. This is the first one. My numbers are different than yours. You can see that the 15, the 27, and the 8 will be different than yours. But it's important to understand what's going on. So I thought I'd walk through this one with you and we can figure out what's going on. So the first thing we're going to do is find the acceleration velocity of the particle. So before we get started, basically what we have is our number line. And so we have our point moving this way and this way, a point. So just a point moving on the line, back and forth and back and forth. So if you think about it, the dot's just moving on the line. And so the speed at which it moves is modeled by this function. So it's not doing some of the things we might expect where it's not doing any, it's not actually, it's speeding up and slowing down, but it's still just moving back and forth on this line. And that's always been something that's difficult for me to grasp. So the first thing it asks us to do is find the acceleration and the velocity of the particle, which should be no big deal. Okay, and so we're going to go to obtain the velocity. We're going to differentiate with respect to t or time. I'm not sure which one it wants. I'm just going to say with respect to t. So velocity is equal to x prime of t, and I'm just going to take the derivative without worrying about one of the points for a minute. And so I'm going to get x prime of t equals 3t squared minus 18t plus 15. So that's the first thing. And of course, that's equal to the velocity of t. And so 3t squared minus 18 plus 15. And then we just clean it up to 3t squared minus 18t plus 15. And so we can throw that in and clean it up and figure out what's going on. I'm going to go ahead and do that here. Type it and see what happens. So 3t, I mean, you can do 3 minus 1 if you wanted, instead of t squared. 18 and 15. Keep it there, so then 3t 3 minus 18t plus 15. And again, your numbers will be different. Let's see what it says. How I did. Looks like I did good. It's telling me everything's fine. Now I need to find the acceleration. We're going to differentiate again, v of t now, or x prime of t up here, with respect to t again. And so v prime of t, which is equal to x double prime, which is equal to accelerate the a of t, is 6t minus 18. And so going back here, down here we'll write 6t minus 18, and again your numbers are going to be different than mine. And hit submit. See how that goes. I did so great. Okay, now here's the question. The interesting parts are here with where is it moving to the right and when is the acceleration 0. So the particle will move to the right when the velocity is positive, because positive means, either up or down, or positive is up or right. And since we're on our number line, we're looking for where this is positive. So this is we're going to use a sign line to help us here, but we need to figure out what are the critical points of our function here. So we're going to take our velocity, set it equal to 0, and solve it. I'm going to go ahead and pull 3 out, so 3t squared minus 6t plus 5 equals 0. And then we're going to factor that into t minus 5 and t minus 1 equals 0. 3 just sits there. And so t is 5 or 1. And now we're going to do a sign in. So 1 and 5. Now I'm just going to click to begin just to make sure I'm on the right track. I've actually done this section of the problem. And I think this is probably what it will ask me to do, but so step 1, we need to factor. So I started that. -6. Already put the minus sign in for me, and 5, which factors into t minus 1, which I already had in t minus 5. And so we're there, and then by inspection we can see that v of t is greater than when t is greater than 0 and t is greater than 5. So now, so that's just going to be 5. T is in between 0 and 10. So because these are both positive, when I plug in a number between 0 and 10, I'm going to get a positive here and a positive here. Let's do the sign line. Just think about that a little bit more clearly here before I do my sign line, of course, is hiding. Stick that up there. I'm sure those are just 5 and I'm nothing to worry about, but I'm just going to put the sign line on just to be sure what's happening. So I can only go from 0 to 10 because that's my restriction on my domain. And so when I pick a number like 1/2, I'm going to have a negative and a negative, which is going to be positive. When I pick a number like 2, between 1 and 5, I'm going to get a positive and a negative, and so that'll be negative. When I pick a number like 6, I'm going to get all positives. And so what they're saying here is by inspection, we can see that the velocity is greater when t minus 1 is greater than 0. So in between 0 and 1. And when t minus 5 is greater than 0. And alternately less than here. And so we know that. So that's what that is. I don't want to get rid of everything I just did. Yep, there it is. Okay. I meant to that. Okay. So we're going to go ahead and get rid of the work we did here. I'm going to hit submit, make sure I'm right. It would be helpful to actually click on it. So folks, so far so good. Everything's good. Nothing came back funky, but it doesn't seem to have given me the next step. Okay. Oh, I forgot to answer that part. Just kidding. Now, okay, step 2. This is the part where we should be doing our sine lines. So we need to have t greater than 0, which means t is greater than 1, and greater than 5. So between 0 and 10, from 0 to 1, and so 1 or, and then 5. Yep, that's from the sine line. Okay, so I'm going to go ahead and erase the things I no longer need. Really get out of my way. So my sine line helped me do that. Oh, whoops, should be a 1. It's over there. It's not actually telling me that it's an error, but it's not letting me move on. I think I'm good here. Okay, so erasing. I'm going to go ahead and get rid of the velocity function. I don't really need it anymore. Wait, actually, it looks like I'm going to. Okay, so step 2 of 1 for the velocity is we need to set this equal to 0. And so that needs to equal 0, which means this equals 0 and t equals 3. No big deal there. Straightforward. We factored out the 6. Okay. And then now we're going to take the answer we just got, which was 3, and plug it into our velocity. And you notice they're having me plugged into the factored one. So 3 into both of these. And so we have 3 times 3 minus 1 times 3 minus 5, which is 3 times 2 times negative 2, which is negative 12. All right, and that is that. So rectilinear motion is a little complicated. You've got your, they string this out, but basically you're just moving on a line instead of moving in space. And so when we move on to some of the other problems here, and you will be working on this, of course, independently, but an evergreen nursery usually sells a shrub. What's the growth rate, height over time? So this is a vertical line. You've got acceleration due to gravity, object thrown upward from ground, and then again, this is vertical. You can tell with the gravity, you're usually dealing with vertical. Car traveling miles per hour, this is horizontal motion. And then last, this is horizontal tangent line, and again, we're dealing with what's happening with this. And this one will be antiderivatives number 6. So good luck to you, and we'll talk to you soon.